All right, Lee, do you want to kick us off?
Yeah, welcome everybody. We're excited to be here talking about Nemesis. The title of this presentation is Building Our Nemesis, talking about the latest Nemesis 1.0 release and just kind of what Nemesis is. So just as a little agenda, what we're going to be talking about, go over some introductions. We'll talk about the background behind what Nemesis is and some of its architecture. And we'll talk about some new features that we've added in the 1.0 release over the last couple months, and then show off some demos of some of its capabilities.
Also, just kind of heads up for everybody, feel free to drop questions, in the Q&A and all that kind of stuff during the presentation. We're aiming to kind of save those till the end, but feel free to drop them kind of while we're talking, but we will address whatever we'll address as many questions as we can, time permitting.
So just as some introductions, so Nemesis is created by us three people on this call right now. So my name is Lee Chagoye Christensen. I go by Tifkin on Twitter, and I do research here at SpectrOps. That being said, I have a long history of doing penetration testing, red teaming, application security. That's all kind of my background. Been involved with a lot of projects and speaking engagements in the past at various conferences. Have a handful of CVEs. Most recently was one of the bigger pieces of research we're known for is the ADCS research, the certified pre-owned paper that I helped do with Will as well. Max?
My name is Max. I'm a AdSim consultant here at SpectrOps. Do a lot of consulting. Mostly I do a lot of software engineering though. I wrote our internal infrastructure automation tooling, and then author of a few different tools: Satellite, JAW3 Transport, GoFish Notifier, and most importantly Nemesis.
Yeah, he is our Kubernetes and Helm expert, which we will dive into. So my name is Will Schroeder. My handle is Harmjoy on Twitter and GitHub and all that fun stuff. I'm also a researcher with Lee Christensen here at SpectrOps. I've spoken at a lot of conferences over the years, helped deliver a lot of training. I was formerly the course architect for the Red Team Operations course. I'm also a co-developer of PowerShell Empire, PowerSploit, specifically PowerView and PowerUp. Bloodhound, I was one of the original authors. Ghost Pack, which is kind of a collection of security tool sets. Originally kind of C#, but kind of morphed, a little bit beyond that, as well as a co-author for the certified pre-owned research with Lee. So I've written a lot of code over a lot of the years, and for the last year and a half, we've had a lot of focus here on Nemesis. So I'm going to talk about Nemesis's genesis, from kind of red team challenges to data analysis. So I'm going to kind of set the stage for everything of why we believe that Nemesis was kind of necessary for what we were trying to do, and kind of where the whole inspiration for this whole project kind of came from. Also, apologies for my webcam not working. Just had a little bit of malfunction, but you at least can look at Max and Lee's beautiful faces. So, but I'm going to start with just kind of a real quick red team story time with our definitely not AI generated little super cool cyber red team graphic here. But I wanted to highlight one of the problems, a kind of prototypical problem that we tend to see on some engagements. So Lee and I specifically, we've been red teaming together for close to a decade. We've done hundreds of engagements, and one of the kind of the prototypical problems that we'll see is this kind of file triage and file system, file share, and file itself triage. So I'm going to just go through a quick example of that to kind of set the stage. So let's say we have our Cobalt Strike instance here. We have a ton of files that we're trying to triage, on a particular host where we have an agent, we have an implant. We can't necessarily download everything. So we're like, well, this one particular thing might be kind of interesting. We download this program.exe. It's going to download from the agent to the actual team server itself. That might be a multi-part piece of infrastructure with jump boxes and all this kind of stuff. Then somehow I need to sync. Then the next step is I would synchronize that file that I had downloaded down to my kind of attacker host. So I'm doing, implant to team server, control server back down to my actual op VM, things like that. Then I'm going to do some like super really basic triage of just initial basic examination of this. And like, okay, I see that this is a .NET assembly, which is something that we like to target because there's often a wealth of deserialization vulns and things like that. So from there, I need to take that and transport it to a non-Windows connected, or sorry, non-internet connected Windows analysis system to do more specific Windows.NET analysis. I'm going to pull this apart with a number of different programs. So I have to move this to a different VM as well. I can pull it apart into something like deinspy or do some automatic tooling. I can see, okay, in this case, this is a toy example for some JavaScript evaluate little snippet that lets me get code execution. There's actually a recreation of something we saw in a real engagement. But there's a lot of steps here, right? And if we're having to do this, hundreds or thousands or more times, that takes a lot of, it's just the workflow isn't efficient. There's just kind of one example of something we tend to go through a lot. So I'll pass it over to Lee.
Yeah, and that's like the reality of what red teaming is. If you haven't done like red teaming or penetration testing or hacking into things, a lot of that is that process there. You're downloading files or you're running tools and you're having to analyze the output. Sometimes you do it on your current machine or you have to go to other machines, you have to open up different tools. And it just takes a lot of time to do all this triage. And so that's some of the problems that we have as we're doing assessments. Another aspect of this is, as a red team, tradecraft is difficult to scale. So at our company, at least, we have like 20 to 30 red team operators, and everybody has different skill sets. Like some people might be good at phishing, some are really good at cloud stuff, some are really good at Windows stuff. But nobody's an expert in literally everything. That's just the reality of security testing. And so when new stuff comes out, or like there's new technologies that we haven't come across before, how do we ensure that everybody on our team kind of has that knowledge? So how can we scale up knowledge? Another aspect of this is, as Will showed, oftentimes we're using a bunch of different tools on a bunch of different systems as we're analyzing a network. And we could be using maybe Cobalt Strike as our C2 framework, or you could be using Mythic, or you could be using Stage 1 or Nighthawk or Brute Ratel, or all these frameworks, Metasploit, and they're all collecting data about the same network, but they're all kind of siloed off on their own machines, and the data about the network is stuck in all of those different systems. And so it's not being kind of aggregated and being looked at as a whole. Instead, you're kind of locked into those different platforms or the output of those tools. Finally, when you run those tools or when you're performing your assessments, the reality is like sometimes there's just a lot of data that you're dealing with, and sometimes it's really tedious to do. So anybody who's done penetration testing or red teaming knows that like file share triage is extremely beneficial, but it's extremely boring. You're like literally just going to a machine and you're downloading files for hours until you find something that's maybe useful. And as a result of that, not just with file share mining, but in other aspects of red teaming and penetration testing, sometimes things get tedious and our analysis becomes a little inconsistent. And that's just because we're human. Like we can't be perfect all the time, or maybe our skills, like I was a lot more experienced, maybe able to see something in a file or recognize like an API token, and maybe somebody with less experience doesn't realize that. So
there's also to kind of add real quick for Lee, there's also kind of a temporal aspect to where maybe something you saw on the first or second day of an engagement isn't relevant to you then, but it could be relevant later. So not having all this output kind of in one place that's searchable can be a downside as well, because maybe a particular code name or something that you're trying to think of or look for later on actually showed up earlier on when you didn't really realize what it was. So that's kind of like a little additional half thing to kind of add on to all that.
So we built Nemesis to try and address some of these challenges that we have. So Nemesis has some long-term goals, some of which we've achieved right now, and some of which we're still working towards. So one of these long-term goals is to empower analytic capabilities. So we want to, take all the output from these tools that we're running from different, C2 frameworks or whatever tools we're using, and centralize it. And then we can model the target network that we're, trying to assess. And as we model this network, we can then perform analysis on the data that we're modeling. So like when we download a file out of any platform or do a process listing, it'll get centralized, and then we can analyze it and do consistent data analysis across all of those different file types. So irregardless of where we download or upload a file from into Nemesis, it's going to get analyzed the same. We also want to provide down the line some workflow specific operator assistance. So trying to scale some of the tradecraft. If we see maybe there's an attack technique that's possible, we can give a suggestion to the security tester of what to do. And ultimately, that's going to help, enhance our knowledge sharing and coordination and reporting practices that we do here. So we can suggest new tradecraft or we can suggest tradecraft for operators. Also integrate our some tradecraft playbooks that we have into the operator workflow. So for example, some type of attacks are like multi-step and they can get a little bit complicated. So we document some different tools that we use internally in like Confluence or in other areas. And rather than having to go externally to these other sources to get information, we can then integrate that into the assessment or the operator's workflow. So in a tool that they're using on an engagement. And this will hopefully allow us to track progression and do better reporting as we're doing assessments. So, and then finally, because we're aggregating all this data, like one of the reasons we want to do this is to support some of our future research efforts. So one kind of cool thing that you can do with this is then look back on previous assessments and do things like maybe by analyzing multiple networks, you can maybe look for vulnerabilities retroactively that might be in a network, or look for different maybe things that we missed while we were doing an assessment. So it's kind of like a platform that we can use for discovering new attack techniques or different post-exploitation techniques that we could use during an assessment. So Nemesis's vision then, basically it's a centralized data processing platform that ingests, enriches, and performs analytics on offensive security assessment data. So, we're ingesting data from the various tools we're using on assessments. It's getting centralized. And then once it's there, we're going to start analyzing it in a lot of different ways. So some of that's going to be automated. And then some of that will also be output to the operator or the user of Nemesis so that they can see the output and analyze it manually as well.
And obviously, this is, not a new concept that we invented. People have been doing this for a while, is particularly on the blue side. We're just want to apply this for more offensive operations. So collect as much data as you can, centralize everything, contextualize it, and so operators can make better decisions. So Nemesis actually came out at Black Hat last year, right, Lee?
Yep. Yeah, so we released it at Black Hat last year. At Black Hat Arsenal. We're actually going to be at Arsenal again this year too. So if you want to come and say hi to us, we'd love to chat with you there. So it was released last year, and then we just released the 1.0 release, just what is it, a month or two ago. And with a lot of new features that have been added since Black Hat last year.
And we'll touch on some of those features here in just a few slides. But first, I'll pass it to Max to kind of talk about some of the architecture.
All right. So going to talk about the architecture a bit. Spend a couple minutes talking about how all the components work, how the data flows, all that kind of fun stuff. So you need to memorize every component here if you're going to use Nemesis. No, you don't. We're just going to talk about some of the pieces here because there is obviously a lot. There's a lot of small components that go into Nemesis. The main thing I want to show here is the kind of infrastructure design pattern we're using. So we have data coming into, from Nemesis Web API coming into this message queuing system. And then we have individual analysis components that are grabbing data from this message queue, performing some sort of analysis, and then passing data back into the message queue. Then the data gets returned into one of the sinks, one of the two sinks we have, either the Elasticsearch connector or the Postgres connector. The data flows through the sinks, outputs to some sort of data source like Postgres or Elasticsearch, and then operators can view that data in the dashboard, or if they really need to get into the nitty gritty, they can use Kibana to analyze it. So that's generally the design pattern we have. Analysis being performed, or a messages going through a queue, analysis being performed, and then data coming back into that queue and then displayed later.
And one of the things I just want to
Yeah.
mention here with some of the connectors and stuff on the left is we have connectors for a lot of major C2 platforms. So if you set these things up, so you have your Cobalt Strike or OST Stage 1 or Mythic or whatever C2 connected up with the proper connector for Nemesis, your files and data and information will just automatically flow into the analysis platform, and then you can just view it popping up in a dashboard. So we tried to make things as end-to-end seamless as possible. Again, you definitely don't have to know how all these pieces work.
Yeah. And then one last thing to note is that we're kind of orchestrating all of that with Kubernetes. Very useful tool. So here's what an example looks like of how data flows through the network. So we start, an operator will download a .NET assembly from the target environment using one of those connectors that Will just talked about. So for example, we might use Cobalt Strike, run the download command. The Cobalt Strike connector will upload that file to Nemesis. And then now in Nemesis, we have a .NET assembly with some metadata about it, and then the actual assembly binary itself. That file is uploaded to min.io, and then we pass that metadata into the message queue. And then the file processor will take it, the file analysis processor, the file analysis like container will see that exists, see a file that's a .NET assembly exists, grab it, and then perform some analysis on it. So inside the file processor for .NET assemblies, we have 3 separate analyses. We have metadata extraction. So it'll grab things like the version info, the imports, type ref signatures, things like that. We'll also run Matt Hand's inspect assembly tool to check for deserialization vulnerabilities on every single assembly that gets passed through Nemesis. And then also for every .NET assembly, we'll use ILSpy to decompile the binary and get C# out. So for every single binary that goes through, these types of analysis are being performed automatically every single time. Then we reach the data sinks. So after the analysis is performed, it goes back into RabbitMQ, back into our queuing system. The data reaches the sink. We get to either Postgres or Elasticsearch, and then Kibana or the Nemesis dashboard will reach out to these data stores and then display data to the operator. So from the operator's perspective, most of this is transparent. From an operator's perspective, you download the file in your C2 platform of choice, and then you look at the Nemesis dashboard to see what sort of intelligence Nemesis gathered from that. So this is what the an enriched file looks like. So after a .NET assembly is passed through, this might be what you see. So at the top, you can see, we found JScript evaluate being executed inside the binary. It says has command execution true. So this will be super useful for us to go and triage and see, where is that potential command execution called. We have the extracted source URL you can see in there. Download it and grab the source. And then we also have all this metadata at the bottom about, where that binary came from, what's the host, when was it downloaded, and so on and so forth. One of the important pieces, because we get this question all the time, is there's this metadata.expiration field. Obviously there's data retention policies that companies have, and we can't just download people's files forever and keep them. We have to abide by the data retention policy. So this field is configurable. And after the expiration date has passed, data will be deleted from Nemesis in any sort of persistent store. So you don't have to worry, if you configure this field, data will be expired and expunged.
Yeah.
And this is
sorry, go ahead, Lee.
Raw data too, the kind of raw view of the data that gets fully enriched inside of Nemesis. There's a much prettier UI dashboard that we'll show you in a little bit that displays a lot of this information in a much friendlier way than just the raw data that you're seeing here.
And then tool integrations. So integrating a tool, now we're going to talk about the left hand of that diagram. So this is ingesting data into Nemesis. It's super easy. There's 2 post requests. If you can make 2 post requests, you can integrate your tool with Nemesis. There's the file API that uploads files, and then there's the data API, where all you have to do is follow this operational data reference, which is a schema that we use for data that gets uploaded. You can integrate your tool with Nemesis. So the ODR, or operational data reference, again, it's just a schema. It includes things like file listings, file data, process listings, so on and so forth. We also have a raw data type in there. So if there's a particular data type that you want to work with, or you have that you want Nemesis to work with, you can use that to start. And if you find that data type to be extremely useful, make a PR and try to integrate that into Nemesis. We also have a number of connectors, so you don't have to write these tool integrations. You're not starting at square one. We have integrations for Cobalt Strike and Mythic, Metasploit, OST Stage 1, Sliver, and we have a couple weird ones. We have a Chrome plugin that uploads files. It's a Chrome extension. Anytime there's a file downloaded in the browser where the extension is installed, it'll upload it to Nemesis. And then we also have a BOF for registry collection. I believe this BOF only works with Cobalt Strike, but it's also there and might be able to be adapted to other platforms.
Great. So Nemesis does all this analysis, and some of our goals behind this is we want to collect this information to help automate some of the boring work that we have to do. So we kind of view this as the equivalent of level 1 analysis of offensive data. So there's a lot of boring and tedious things that we have to look at and remember to do on assessments. So let's just try and automate away as much of that as we possibly can. We can also do this offline rather than doing it in the target network, which is nice. Another nice thing about this is because we're building this data model, we can also analyze the relationships between data sources that maybe weren't as easy to do previously. So we're a simple example of some relationships on a host are think of a Windows service. So Windows service is backed by a registry key, and in that registry key, it defines the path to a binary on disk. So these are all different types of data types in Nemesis. You have a service, a registry key, and a file on disk. And you can see that there's relationships and there's value in those relationships, in that you may be able to, by analyzing them, you can find things like privilege escalation opportunities. And that applies elsewhere in the network. So for example, you have a host. Well, a host is individual by itself, but you also have hosts in Active Directory, and there might be users on those hosts, for example. So we're building relationships in this way too for different systems. And then as we do this analysis, down the line, one of our goals is to provide feedback to operators and give them suggestions based off of what we're seeing in the network. So, they're using Active Directory. We see that SCCM is registered. Maybe we queried the registry and we saw SCCM is registered as being used on the host. So maybe you should do some of the SCCM related attack paths like sharp SCCM to discover credentials or escalate your privileges, things like that. It's a simple example of how we can provide feedback to an operator.
Yeah, and to be clear, this is one of the long-term goals. There's a lot of plumbing that went into getting to this particular point, which Lee will get into in a second, particularly around some of the host-based abstraction modeling that we'll talk about. But this is kind of the ultimate goal that we want to get to, is contextualizing your operations with existing data and integrating playbooks and things like that. So not quite there yet, but that's where we're working towards it. All right, so we're going to talk about some of the new Nemesis 1.0 features, starting with that host modeling thing with Lee.
Yeah, so one of the things that Nemesis tries to do is it's responsible for processing and enriching data and building a data model that we can use irregardless of the tool it comes from. So like we said, we support a lot of C2 platforms like Metasploit, Cobalt Strike, Mythic, etc. And this is great because it allows us to get data from a lot of different sources, but it comes with its own problems because every platform identifies hosts in a different way. And so this problem, so for example, some platforms may use the NetBIOS name. They could use the IP address. They could use both. They could use the FQDN. Sometimes when you get an agent back, as when we're doing like red teams, we may not even know what the host name is because we're using like DNS C2. Other platforms try and generate a unique artifact per host that you get on using things like the serial number in the hard drive. And so how you do host identification can vary. And so we had to solve that problem of, given that we have data coming in from multiple sources and we're trying to aggregate it and build a data model, how do we aggregate that and uniquely identify hosts? So we may have, a Mythic agent running on a machine and a Cobalt Strike agent running on the machine, returning data about the same host. And we basically need to collapse that into a single host. Well, a single host representation. Sometimes, though, it's not always easy to do that, and mistakes happen. So I've seen other projects try and solve this, and they map things incorrectly. So a very simple example is, let's say we have two agents running on two different machines, and they have the same NetBIOS name. So let's just say like computer one, but they're running in different domains. So computer1.corp.local versus computer1.acme.local. The agents, though, may only be returning the NetBIOS name, and it's actually two different machines. So sometimes errors happen, and we wanted to be able to support remapping, either manually or automatically, to the correct host representation. We also have some what we call temporal problems. So when we're collecting data, the ground truth of things can be composed of various pieces of information. So imagine a file system like a Windows file system. It's huge. There's a lot of different data there. And when we're doing our collection, a lot of times we're doing it kind of piece by piece. We're going to list a directory here, list a directory over there. And you may be doing that through multiple platforms. And the tools you're using may be returning data immediately, or it could be very delayed. So you can imagine like when you're using DNS C2, it takes a long time to exfiltrate data from the network. So data might arrive at in a delayed fashion, or it may just be partial data. You're not seeing all of the file system, you're just seeing a part of it. So when you're building a data model, you have to take these things into consideration. Like, what if we're receiving data, we listed the file system and we don't get a response until, 5 days from now. We have to be able to model that correctly. Another problem is, how do you differentiate and track data that's collected on one host versus, I as an attacker might be on a host and then querying a remote host and collecting data from a remote host. So how do we differentiate between data on the current machine versus a remote machine in the network? And that creates some very interesting host modeling challenges. And we did a lot of whiteboarding to try and figure this out. As you can see, this is some of our brainstorming sessions. We'd say it definitely wasn't easy, but we have a solution. We don't know if it's the best solution, but it's a solution. So that is all. It's in Nemesis, and now we're going to start building on top of that to build out some more analytics, some more powerful analytics that we'll be able to use in the future.
Yeah, this was a surprisingly hard problem, but But again, we think we have a solution, and we're actually going to be releasing a blog post probably in the next like month or so, I think, Lee, that kind of details and some of the specifics on this. So if host modeling is just, is just your jam, then be on the lookout for that.
We also streamlined the installation for Nemesis. So this was by far the biggest piece of negative feedback we got about Nemesis, pre version 1, which is totally understandable. One thing that I loved was Checky Mander or Scotty Austin wrote this giant blog post detailing how to install it. It was like, huge document. And he very politely called it an intimidating install, which is just the understatement of the century. It was not an installation that was for the faint of heart. Things are a lot better now. So we got rid of Nemesis CLI. So if you've installed Nemesis before, you had to use Nemesis CLI to configure it. We're now using Helm, which is an industry standard. It's a how would you call it? Like Kubernetes package manager, essentially, for deployments. So we're using that significantly easier there. We also publish the Docker images, so you don't have to rebuild them every single time. And we dropped Minikube in favor of K3s. K3s is awesome if you've never used it before. Very easy to set up and use, has a ton of features built in, and we're pretty much entirely integrated with. We can deploy Nemesis on top of K3s easily. The installation process is, significantly streamlined. The installation is now technically 5 steps. I'll say it's 5 steps. The quick start guide has 8. 8 steps listed, but 3 of those are how to access Nemesis. So from nothing to being installed, it's 5 steps. Significantly streamlined. We've got a demo of that in just a second to show you, show it off. Here, I'll quickly go over this. We've got the top image is the Helm templates. So you can see now we're using Helm. We have how to install K3s. So if you used Minikube in the past, you'd have to install Minikube, set up the memory, set up the number of CPUs you wanted, start the little virtual machine it has in it. With K3s, it's just as simple as curling, piping to bash, everyone's favorite thing, and then doing a little bit of configuration. What's nice is this is copy and pastable, so you can just copy and paste this config and K3s is set up. And then at the bottom, you can see the Docker Hub. We published all of our containers to Docker Hub, so you don't have to build those yourself anymore.
Yeah. So also we'll show in the demo, but from start to finish, it's usually less than 10 minutes to get stuff up and running. So it's hard to really kind of overstate how much better this is. And like Max did a huge amount of work here to just make this way more manageable.
Yeah. Also, this is the most beautiful thing in the world. I've tweeted about this like 3 or 4 times. I love this documentation page so much. So big shout out here to Matt Alpha on Twitter, or Matt Urschwender. He wrote a PR for building this documentation. So now you don't have to go through the docs folder, all the markdown files sitting in there. It's beautifully set up here. You can go to it at spectrops.github.io/nemesis. It comes up. You can see if you want to get started with Nemesis, like install it really quickly, there's the quick start guide down there. And then if you want to dig into more of the documentation, either the services or how to develop it, so on and so forth, that's all listed here.
We also have usage guides and all this kind of stuff. So there's, probably close to 100 pages of documentation throughout this. So it's definitely way nicer. And also this link, that spectrops.github.io, that is kind of on the right of the main repo page too. And this gets dynamically built every time that we modify documentation pages. So it should always be up to date. One of the other 1.0 improvements was the text search backend. So anytime that there's a document that can have text extracted from it, so PDFs, docx's, Excel documents, .log files, whatever it is, that text actually gets extracted and indexed in the backend Elasticsearch component. So we spent some time revamping this almost completely from scratch. So we're going to show this in one of the demos, but we kind of have full document by document text search, as well as kind of what's called semantic and fuse, like kind of fuzzy BM25 text search for Elastic. So we're just doing kind of some traditional text search fused with kind of this semantic language model driven text search, which don't quite have enough time to dive into all this. There's a blog post that I'll cite here in a bit that goes into a bunch of details. But the reason for doing that is so we can actually build some kind of cool NLP driven type stuff in the back end. But again, all these documents with extractable text are processed. They have their chunks semantically indexed in Elasticsearch. TLDR, this allows you to even run stuff like an LLM-powered chatbot over text from documents that are pillaged from C2. So outside of just the normal kind of let me search all the documents I've downloaded like you would with Google of having one document for each results, you can actually use this is a somewhat proof of concept, but it seems to work. If anyone actually uses this in the field, let us know how it kind of works for you. It's still, a little bit of the cutting edge, but we released a tool called Ragnarok that's a Nemesis powered offensive, like kind of LLM chatbot, to where it uses a locally running large language model where you can connect the interface into a Nemesis instance with the creds. And when you ask a question, it'll search the backend for relevant text snippets extracted from downloaded files, and then use that in a context that's fed to the final LLM after doing some re-ranking and a bunch of fancy NLP stuff. And it'll let you ask questions about documents that you have downloaded through your C2 platform, as well as having links back to everything in the dashboard and Elastic and things like that. So this is just an example of some of the stuff that the backend text search lets you build on. We also have the Hasura API. So we've had Kibana kind of in Nemesis from the beginning. It's kind of the GUI front end for the Elastic backend. But there wasn't really a super easy way to access the structured data in Postgres. And again, we kind of have data in two places. We have it semi-structured in Elastic, and then we have it highly structured in Postgres, so we can do things like link DP API keys with blobs and things like this, or those registry keys to services and all that type of stuff that Lee was talking about. So we integrated a new Hasura API. It's a really awesome project that lets you construct GraphQL and REST APIs on top of existing Postgres databases. If you have Postgres in a project, I would highly recommend checking this out. We actually, our team, like Cody, it's a feature, uses this for Mythic. So this lets you do basic scripting for processing existing data, as well as doing subscriptions for new data as it comes in. So you can actually set up a subscription of, say, if a new file of this type is processed by Nemesis, like let me know, then I can extract information about it and do some type of additional things. And we have documentation on this on the website under Hasura, and we have examples for doing this. But the main Hasura GUI, you can actually see here, it lets you very easily explore the backend data model. It might look just a little bit weird, but if you actually play with this, it's super easy to use. It lets you pull out specific fields. It lets you do filtering, and then you can actually see the results in the end. So this is kind of the exploratory component. And then you can use these particular queries or subscriptions in your own scripting. So we basically get a scripting engine for Nemesis for free by using Hasura, which is pretty awesome. Again, it's all documented in the main documentation page. So there's also a ton of different like dashboard features, fixes. There's a ton of different things, but those are kind of some of the main areas that we were able to develop for Nemesis 1.0. And now we're going to hit a couple of demos, starting with the streamlined installation.
Yeah, so here's our awesome install process. First, we'll do the quick start guide. You can go to our beautiful documentation. We'll start by installing K3s. So as you can see, copy, paste, K3 starts, and you have Kubernetes running. Then we'll install Helm, get the, basically what this is gonna do is just get us the Helm binary, put that in our path. We're gonna start the pods, start monitoring our Kubernetes cluster before we start installing stuff. So we're gonna install the Elastic operator. This is the required for installing our Elk stack. You can see that installs successfully. We'll install the quick start chart. So this is just some dependencies for Nemesis. You can do all of that manually. It's just setting up secrets and TLS certificates, things like that. And you can set those up manual if you want, but need those before we install Nemesis. So if you pause it here real quick,
Yep.
I'll go over this. The inside of, if you're going to install this on a remote server, there is a IP address flag that you can set. We're going to delete that here because we're just going to do a local installation. So you'll see Will like delete some stuff. The default value for this flag is HTTPS 127.0.0.1 port 443. So we're just going to do a local installation, not worry about it, and install Nemesis that way. So we start the install process, come back after a couple minutes. You can see all our pods are creating, and now they're all running. So Nemesis is installed. That's the 5 steps. The 5 steps you need to install Nemesis. That's it. Now we're going to access it. We're going to grab the basic auth username and password. And go to localhost. Enter that username and password that was automatically generated, and we got our dashboard. So Nemesis is fully installed. You can access it, everything in just 5, technically 8 steps.
And also to kind of add on with that, the main basic platform that we've tested and supported for this is just kind of stock Debian. We have all the requirements and specifications and stuff like that on there. But we're hoping to expand this for like additional platform for support now that we have K3S. It is significantly better supported than doing the Minikube and Docker and things like that.
Oh yeah, actually one thing I wanted to add, I did a lot of testing and development on Windows with Docker for Windows. There's a couple things. There's a small guide in the documentation if you want to set it up with a different Kubernetes clustered, something else running Kubernetes. So it is possible. It's not that difficult to do. It's just K3s is what we support. It's what we support with issues and stuff like that.
Cool. So we're going to do another demo real quick, highlighting some of the PE file analysis and the UI interface. So we're going to upload a binary into Nemesis, whether through a C2 or through the web interface. So that's what we're doing here. That's a .NET assembly. So we're going to go take a look at the uploaded files now. And you can see that Nemesis analyzed it, identified a command execution primitive. It also does a bunch of things underneath, like decompiling the source code. So we're gonna go ahead and download that decompiled source code now. There's a button to do that. So we'll go ahead and download it. We're gonna unzip it, and then we can see inside of there that that vulnerability primitive that Nemesis identified. So again, this did this really nice analysis for us that we no longer have to do manually as an operator. If we go back to the Nemesis UI now, we can add comments on the files. So this is great if you're working at a team, and then mark it as triaged. So I hit the little up arrow there to show it was triaged. And now my team members know that I've looked at this file and they don't have to look at it again too. So it's great for working in team environments. All right. We can also view detailed information about all files. So that's what you're seeing here. It has a built-in Monaco editor, so it'll do things like syntax highlighting, and you can just quickly see the contents of the file. So you don't have to open up another program. If it's certain types of text documents like Word or RTF files, it'll convert it to a PDF, and you can view it from this page as well. So that's really nice. Well, you can see the comments and everything there. You can also view the raw information about the file by going to the Elasticsearch info, and you can see some of the other analysis that Nemesis did underneath, like extracting PE metadata information. So you can see like when it was compiled, some PE information like the file name and the copyright. It also pulls out things like the imports of the PE file, the exports. Since it's .NET, it's also pulling out the types that are being used, the type refs, the .NET version, et cetera. This is just like starting to automate some common reverse engineering tasks that I as a operator have to do when I'm analyzing binaries. So now that it's in a structured form, Nemesis in the future could either use this data, or as an operator, I could write my own tools to download this data and do my own analysis.
Yep. And also all this data is obviously available in Kibana and Elastic, so you can do your filtering and queries and things like that as well. This is just a shortcut way of showing kind of the JSON dump. All right, and our last demo real quick, and then we have just kind of one more slide after this, and we'll have some time for questions. But I'm going to show some of the improved file processing and document search. So through the interface again, I'm going to upload a number of files. So there's several PDFs and like kind of one text-based example config. Now, as things are going through here, Nemesis is going to take those PDFs, extract all the text using Apache Tika. It's going to index everything, chunk all of it up, and do post-processing on that. So for one example, we actually have some sample files in the Nemesis repo under /sample files. So we have a nosy Parker config, which is an awesome tool that scans for automatic like passwords and tokens and things like this. So we see it's tagged with nosy Parker results that we can actually click on. We kind of see our universal nosy Parker results. It's an example Google OAuth token. We can go to the individual file details for that. See that nosy Parker config. We have that Monaco editor. If this was some kind of source file, it would automatically detect the extension and do relevant syntax highlighting. And we also see those a tab just per file for those nosy Parker results that show those secrets that show up there as well. So I marked that as triage, so it hit it for everybody, even though you can make those show again. We also run a series of YAR rules against everything that gets pulled. So there was a subverting sysmod paper as one of the SpectrOps white papers. We see there's some YARA matches for hack tool strings pwn shell. So we actually see the invoke Mimikat string will be scanned for and actually alert on this. So for here, I'm actually just going to view that PDF automatically in the browser. And we see there's that invoke Mimikat string that got extracted. But again, this will do this for, YAR rules will be checked for basically all files, including text or anything extracted as well. Now I'm going to go to the document search and show, we can do document by document searching for like searching for escalation 6. This will show one result per document that actually matches if you're searching for code names or stuff. So this is kind of like a Google search for all documents that you've downloaded. And again, not just searching text files, but it searches the raw text extracted from any document that can have text extracted. You can also search for something like token. And it shows, a couple of results as well. And clicking on those PDF results will take you to the relevant file in Nemesis. And then the snippet search is what's every chunk of text gets, or every big bit of text gets chunked into about 500 words a piece and indexed with that semantic search. So this is what's driving that kind of LLM chatbot in the back end. You have all these different chunks that actually get pulled back. So instead of just searching one document at a time, you're searching for like relevant subsections of the document. And this is what powers that LLM chatbot, and if you choose to use that as well. Just showing kind of the Elastic interface as well. We have our raw, plain text files. So we see this text field would be all of the extracted text from that certified pre-owned white paper, which is over 100 pages. It was able to extract it out and index it. And as well as the kind of semantic text embeddings as well. I'm going to show that. So I think got just one more kind of slide real quick. We'll just kind of summarize and we'll make sure we have some time for some questions. Oh, go. There we go. All right. Take it, Lee.
So yeah, this approach that we're taking with Nemesis, we're excited about because it gives us as a team a lot of advantages that I hope others can use. So a simple example is we can update the analysis workflow for all operators. So think back to that vulnerability that Nemesis identified in a binary. That was actually a real world example of a vulnerability primitive we found on an assessment, and we were able to exploit it and get external access into a network. And we added that into Nemesis, and now all operators benefit from that going forward. So we added that logic in, and now anytime somebody downloads a PE file, that'll be identified for them. if it is present. So that's going to help everybody in perpetuity going forward on all of our operations. By collecting all this data, we can also do retroactive analysis. So we can look at the data that was collected and maybe find new attack paths or new post-exploitation techniques. It can also allows us to minimize the footprint on of our tooling on host. So our tooling has to focus on collection rather than doing collection and analysis all while on the host. And that's ultimately it's going to help assist with some evasion of defensive products. And then we can use all this collected data, kind of like I said, whether structured or unstructured, to guide some of our future research efforts. So we've collected the data and like doing things like a lot of data science ML, you need data to analyze. And so that's going to provide us a data source. And, you know, this is great. The installation now is also very manageable. So huge shout out to Max there for the great work he did, making that much more streamlined.
All right, so that's the content we have. Thank you all for attending. I know, Lee, do you mind taking kind of the Q&A thing while I leave it up on this slide?
Yeah, we had a few questions that came in already. One question from someone had is, does the document converter parse external images in the docx format? They were worried about like canary tokens. So with our our document converter, it lives in a Docker container. And we isolate that container so that it doesn't have any outbound network communications to block canary tokens.
Specifically around canary tokens. So whenever it opens up, we're using a Gutenberg container that converts everything to a PDF as well as Apache Tika to extract text. But for Gutenberg specifically, we cut off internet access just for that container. So it can access the internal cluster but can't reach out. So when it gets converted over to a PDF, obviously we haven't tested this with every possible version of canary tokens or whatever else, but we have tried to put some protections in for that.
Yeah. Had another question asking if it's like a sandbox analysis tool. I'd say not really. I'd say it's not focused on the defensive side of things, but it is similar to what some defensive teams have. You can upload data into a lot of defensive teams. You can upload a binary in there and it analyzes it and it does things with it. Nemesis, besides just analyzing PE files, it analyzes any offensive data that we use. So that could be like a process listing, a file listing, services that we enumerate on a host, registry keys that we're seeing, as well as files that we are downloading. So it's ingesting a lot of different kind of data constantly from our C2 or the tools that we're using, and then building that data model and doing its analysis kind of in real time. Got a question about the system requirements for Nemesis as well as Ragnarok. If you look on the documentation for Nemesis, there is our recommendation. So we say, I believe it's 4 CPUs and 16 gigs is just our kind of baseline recommendation, because you're running a K8s cluster, Kubernetes cluster, and that seemed to work well for us. That's what we've used during our testing and as we've used it. Will, do you want to speak to the Ragnarok?
Yeah, for Ragnarok, again, as much as we'd like to, we can't just shove an LLM into the Nemesis cluster because we can't assume everyone has GPU and that amount of RAM and all that kind of stuff. So if you're running the large language model offline for Ragnarok, you need a GPU. So I think the model is a quantized model that's around, it's like one of the 7 billion, if you're familiar with the parameter stuff, it's a 7 billion parameter model quantized down to, I think, like 5 bits. So it takes about like 4.5 gigs of VRAM. If you have an 8 gig VRAM card, that'll work. If you have any of the Apple silicon for M1, 2, or 3, they have the unified memory. It works very, very well for that. Outside of that, you can technically run it in RAM. It'll just take a lot longer. So you essentially kind of need a GPU. But thank you for the question, because I need to go actually put some better system requirements on the Ragnarok documentation. So I'll try to make that better documented.
Had a comment saying parsing OST files would be great to search for passwords and interesting attachments. We have a lot of additional file types that we'd want to support beyond just what we currently have. There's a component in the enrichment container where all of our enrichment of files happens, where we have a bunch of file parsers And PRs are welcome if you want to add in a parser there for OST files. But it would be great to have that. It's definitely on our list of interesting things to look at.
Yeah, Leah just mentioned, like every time we deploy this type of thing for engagements, we have ideas and things that kind of come up and additional file types and all that. So we have more modifications that we'd want to do than we possibly have time. So it's a very, very big ongoing list.
Yeah. Had a question. Maybe I missed it, but were you able to drill down from the LLM search directly into files and documents? Will, I'll let
Yes.
you talk about
So
that.
for the Ragnarok, I'm just going to back up real quick to kind of that interface. I'll just show you. Let's see. Almost there. Okay. So the links in this is again, it's a separate application to where you give it credentials like into Nemesis. When you ask the question for the LLM, that where that little blue certified pre-owned is, that actually links you to the file, the originating file in the Nemesis dashboard. So it lets you like drill down for where it came from and all that kind of stuff. And then the individual snippet of text, those like 500-word chunk snippet of text that was used to form that part of the context, that is linked with that snippet and elastic link right there. So whole originating document as well as the individual bit of text that had that bit of information to form everything, those get cited right there and let you link right to it.
Cool. One more question. I think we're they asked, is there any utility for pen tests like external or web, or would this be overkill?
Right now, I think it's mostly focused on post-exploitation. Because again, that's where we saw a lot of kind of the downsides in the workflow, or kind of not flaw, just challenges in some of the workflows and stuff that we've encountered. This could be expandable to like anything for kind of a post-processing enrichment pipeline. That just the focus has been we didn't want to have scope creep of saying like we're going to analyze just everything forever or whatever. Like we wanted to try to focus in on some particular use cases first, which tends to be post-exploitation. So it doesn't do anything web specific, but you could expand the architecture if wanted. But honestly, at this point, it's probably a little bit of overkill.
Yeah, it definitely could support it though. Like in my mind, I've thought about adding an OSINT data. Like we could add in entities for like domains and you could do like website analysis. You could have scrapers, like some automation for a lot of the OSINT activities that you have to do if you wanted to. But it just wasn't our focus because there's a lot of OSINT tools that do that already. So we could maybe integrate them in at a later point. Again, PR's welcome. I think that's it for now in terms of the questions. Just a reminder again, we are going to be at Black Hat if anybody's going to be there. We're presenting on the 1.0 release at Black Hat Arsenal. We're also going to have a booth at Black Hat. So feel free to stop by. We'll be hanging out around there. And we love chatting, with people. We love chatting about Nemesis, about any of our tools. And so we'd love to see y'all there too. And feel free to reach out if you have any questions about anything. We're more than happy to answer where we can.
And we'll release kind of a PDF version of the slide deck. We'll tweet it all out through, it'll be retweeted by the Spectre account coming from our accounts. And last bit is we actually, Lee, Max, and myself were in the Bloodhound Slack. And we actually have a Nemesis channel in there as well. So if you have additional questions or anything, you can reach out to us on Twitter. You can reach out to us on the Bloodhound Slack, or kind of whatever the medium is that's easiest.
Thank you, everyone.